Hi there, this is Nick Mason from ProofSpace. Very happy to be sharing with you the closeout video for the project PRISM VC Schema and Credential Definition, which was funded with 27,685 USD in the Open Standards and Interoperability Challenge of Catalyst Fund 8. The output of this project is a standard representation of a PRISM credential schema and credential definition, and with that, a set of open source tools for verifying this standard and defining a way to store a schema in persistent storage. So what is a credential schema and a credential definition? The role and importance of schemas in self-sovereign identity is well captured in W3C documentation, links for which will be shared in the closeout report for this video and the YouTube details. The brief summary, though, is that a schema is a template for a verifiable credential. It's often written by a governance authority so that it becomes the standard for all the organizations that defer to that authority and can be published for public use or private use. As an example, if you have a group of universities within a particular state or county, they might defer to the local government for education credentialing details, or they might form a consortium with the local government, and they might agree as a group to issue degrees and diplomas and learning outcomes according to a particular set of attributes within a credential. The schema therefore tells the issuer, the holder, and the verifier what information must be included for a credential to be valid. So, for example, a degree might contain the student's name, the student's graduation year, the degree that they took, and the grade that they received in that degree, just simplistically. For scaling self-sovereign identity, these schemas become incredibly important because employers and other verifiers downstream, perhaps other higher education institutions, need to be able to verify the credential against a consistent format. And that creates trust in the system. And all of the issuers who are able to issue credentials against that schema are part of what's called a trust registry, which is formulated by the governance authority, and admission to the trust registry can be granted on a number of different levels. So that's a brief overview. What the project enables is a set of open source documentation and tools for implementing this critical piece of the SSI infrastructure for Atala PRISM. It also really opens up the possibility of building ecosystems and trust registries, which is a target for the self-sovereign identity landscape, where you get reuse of credentials outside of the service that originally issued the credential. And that's where we start to gain real utility from our verifiable credentials. And also the tool being built into the ProofSpace platform enables that capability in a no-code capacity for any of the users of that ProofSpace platform. So there's detailed documentation about the tool itself via our GitHub. And the closeout report contains a lot more detail about the technical achievements. We had great engagement from the Cardano community during the project, and hosted an Atala PRISM Catalyst after town hall meeting, which was well represented by the PRISM community in particular, where we had feedback and contributions to the project, as well as a general endorsement for the direction that we were taking. So really happy to see this be adopted by that community, and what we hope is that the community will utilize the tool in their own implementations of Atala PRISM, or indeed through ProofSpace. We'll invite the Atala PRISM core to use the tool. It can be an opportunity for learning for Atala PRISM pioneers, and also a practical tool for them to take forward their projects to implementation. And of course, we'll continue maintaining and improving the tool and expanding the documentation so that developers that aren't familiar with SSI will be able to utilize it. On that note, I will hand over to the demo, and hope you enjoy it. Thank you very much.
Let's start from the scratch. The credential definition schema is based on the meta schema. Meta schema structure is represented here It includes the meta info with the based information, objects and primitives, what are the body of the schema. So meta info include the name, the version, trust registry, author, and domain uniqueness. The objects, it's like a node in the credential definition, and it includes an array with the values. Primitives. We use the most common primitives, like a string, number, it can be either integer, decima, or float, boolean, enum, date and timestamp, can be issue date or expire date, duration, and images and binary data, what is well known as a base 64. And now let's go to the examples. Here we go, the most primitive credential definition schema. It has the name of the schema, description, ID, the markup, we use the schema.org markup there, version, author, trust registry with permissionless type. It says that we have no permissions, and properties with given name and family name with type string. So this credential definition schema is equal to this credential with given name and family name properties. As you can see, both of them are strings. So now let's do the magic and use our tool to create the credential definition schema. Here we go. As you can see, it says type object, additional properties equals to false. I will talk about this attribute a bit later. And our properties, given name with type string and family name with type string. Both of these properties are required, and schema is the markup, credential definition markup. So here we go. We have already created the credential definition schema, and now we can generate JSON LD context. So let's take a look into a bit complicated schema. These properties we have already known, so let's go to the properties section. Given name property with type string and the new attribute context URI. Context URI means that we should stop processing this property and use this value as a base. The next property, family name address with type string, amount decimal, whatever. Gender. Gender has enum type, and this is how it looks like, as a list with a type with the strings. Employed is boolean. Geo. Geo, it's an object. Object in object. And like the end of the properties has the primitives type integer. Skills, it's array of string. Binary, it's object of string, cause base 64 it's the string. And the proof with type object and additional properties set to true. This attribute set to true means that we should stop processing this object and just left it up. And now let's convert this credential definition schema to the context. Here we go. And let's take a look right here. It's the same context. So what we have there, it's all the properties we've seen, like given name with type ID, convert to text, float integer, whatever. this one, like we handling create a JSON of the context and credential definition schema. So now we can generate JSON of the document, which is based on the W3C standard. This is the command. As the first parameter, we pass our credential definition schema. The second one is our credential, what is obviously equal to the schema. And we have several parameters. The first one is context. It can be either inline or external. Inline means that we put our context inside the JSON document, like here. And external means we have stored our context on server, and obviously we have resolver for one, so you just need to pass the second parameter base context URI. Let's say it's https ProofSpace.id, and here we go. So this is the path for, this is the URI for our context. As you can see, it stores in the JSON the context folder, and this is it. As you can see, our tool is pretty easy for use, and feel free to add any issues if you struggle with, and welcome on board.